myself K. Siddhartha. I am from the printing department, B section. Today we are discussing about what is diversity factor and how it affects in the power distribution in power system subject. Let us see. Understanding the diversity factor in power distribution. That means we have to understand the diversity how in power distribution. This presentation will optimize the grid efficiency and reliability. We will reduce the infrastructure cost through capacity planning. We will also cover the impact on power distribution networks and consumer usage patterns. Next one is defining the diversity factor. What is meant by diversity factor? We will see. Diversity factor is the ratio of sum of individual maximum demands. This is relative to the maximum demand of the entire system. The We have to calculate the diversity factor. We may use the formula as diversity factor equal to sum of individual max demands by maximum demands of group. It is always greater than 1 and reflects non-coincident peak demands. In the right side diagram, we can see this is the example. In that, consider 10 homes, each with 5 kilowatts, max demand totaling 50 kilowatts. The peak for all 10 homes is 30 kilowatts. Then the diversity A factor will be. In that example, we can see that they may consider 10 homes, each with 5 kilowatts. The demands the totaling 50 kilowatts, and they are mentioned the time for 10 homes. 10 homes is 30 kilowatts. Then they ask the diversity factor. We can use the formula in the diversity ratio, sum of individual max demands by maximum demands of group. That is sum of individual mass demands is 50 and the maximum demands for the group is 30. By 50 by 30 that equal to 1.67. Next one is calculating the diversity factor. In that, first one is the data collection. Collect the individual consumer load profiles over time to identify the trends. And the next one is the peak identification. Identify peak demands for each customer or load. We have to identify the peak demands for each customer or a load. And the summation and comparison. Some individual peaks and compare to the system peak. And the AMI data used advanced metering infrastructures for data analysis. We can use the AMI meters for to collect the data and for calculating the diversity factors. So this is the way to calculate the diversity factor. And the applying diversity factor in power system design. That means how we can apply the diversity in the power systems. In that, the first one is the capacity planning, and the next one is the cost reduction, and the next one is the system reliability. By applying the diversity factor, we can reduce the cost and the system will be reliability, and we can plan the capacity, how it will be based that one. Diversity factor reduces the equipment size and the cost based on realistic demands. It optimizes grid infrastructure investments and resource allocation. This enhances the system reliability. And the next one is the impact on power distribution networks. And the first one is the efficient use. More efficient use of existing infrastructures improve overall performance. And the low losses, low transmission lines and distribution losses enhance efficiency, improve regulation, improved voltage regulation and power stability. So these are the impacts on power distribution and the factors affecting the diversity factor. If we see that pie chart, they may define the climate, load types, and demographics. In the climatic conditions and seasonal variations affects the energy use. In that, if you see the rainy seasons, that may change in the efficient energy usage, like that. And the next one is the load types of loads and appliances penetration rates matters. And the next one is demographics. Customer demographics and usage patterns influence demand. The case studies and real world examples. First one, the X is the utility implemented diversity factors optimization saving $5 million. In city smart grid projects achieved a 15% reduction in peak demand. Industrial facility Z load management strategy improved energy effects. These are the case studies. And finally, the conclusion optimizing the power distribution with a diversity factor. Key role critical in modern grid management and planning. Uh, this is the main key role for the power distribution in diversity factor, and the benefits offers economics and reliability improvements. We can improve and offers the economics. And next one is a continuous monitoring requires continuous adaptations. So this is the diversity factor in power distribution. Thank you.